Well, hi there. This is Robert Font, a certified professional geologist and an active member of the AIPG. I'd like to say a few words about integrating well data with seismic data. The reflectors that we see in seismic sections will allow us to see structural and stratigraphic relationships, but without well control, we cannot be sure of the veracity of our interpretation. In fact, we cannot even be sure about the lithologies that we're seeing. Therefore, integrating well and seismic data is crucial. To integrate well data to seismic data, we use a sonic or an acoustic log. The sonic log records the time that it takes for a sound wave to travel a short distance through the rock adjacent to the wellbore. Knowing the distance that the sound wave travels and recording the time that it takes for this to happen allows us to calculate the velocity. At each boundary between two different rock types, with of course different physical properties, the downgoing sound waves will be reflected back to the surface. Knowing from the sonic log the velocities of the formations and the velocity changes at formation boundaries, we can calculate the reflection coefficient or the reflectivity at those contacts. The reflection coefficient is a measure of the reflectivity at those lithologic contacts, and it depends on the difference in the acoustic impedance of the two adjacent layers divided by the sum of these. Acoustic impedance is defined as the product of velocity times density. If you look at the diagram, the reflection coefficient would be equal to V2 rho 2 minus V1 rho 1 divided by V2 rho 2 plus V1 rho 1. If one passes from a slow layer to a fast one, the reflection coefficient is positive and swings to the right. Conversely, if one passes from a fast layer to a slow one, the reflection coefficient is negative and will swing to the left. The magnitude of the reflection coefficient dictates reflection strength, in other words, the amplitude, and the direction, whether positive or negative, dictates polarity, in other words, whether it's a peak or a trough. The magnitude of the reflection coefficient relates to reflection strength and therefore to amplitude when displayed in the form of a seismic wavelet. The polarity relates to the positive or negative value of the reflection coefficient and therefore to a peak or a trough when displayed as a seismic wavelet. The reflection coefficient spikes can be expressed in the form of a wavelet. These wavelets can be made to look like the seismic section by adjusting the wave phase and the frequency. Therefore, a synthetic seismogram, or a synthetic, if you will, is generated from a sonic log recorded in a well, and then it is matched to a seismic line. In summary, a synthetic can be constructed from a sonic log, and it will allow us to tie the well data to the seismic line. At each contact between distinct rock units, the reflection coefficient can be calculated and depicted as reflection spikes. In turn, these spikes can then be displayed as seismic wavelets, creating the so-called synthetic. When displayed at the proper scale, the synthetic can now be superimposed on the seismic line for reflector identification. Once we have superimposed the synthetic on the seismic line, we can match the reflectors from the seismic line to the wavelets that we see on the synthetic itself. Now remember, these wavelets represent the contacts between different lithologic units. So we can now establish the geologic connotation of the seismic reflectors. Also, we can now trace these lithologic units throughout the area covered by the seismic line. And here is the bottom line. We have an uninterpreted seismic section on the left and a possible interpretation on the right. But without well control, we could not be absolutely sure what these reflectors were. Well, we drilled a well in the area, and from a synthetic, we were able to identify that blue reflector as the base of the Ellenberger. So now we know that anything below that is pre-Ordovician strata. And that's it. Hope you have learned something. Take care. Bye-bye.